verticals, yeah. So you have 1, then you have this one cylinder number 3, then your cylinder number 4, then cylinder number balance, as what we did earlier. Okay, so secondary now, secondary, so put it here, this one is theta is equal to 180. So put it here, secondary force. So you have it 2 theta is equal to, now is 180 is 360. So polygon, this is the polygon. This one is 2 omega, cylinder number 1. And if you can go back to this one, we have all zeros. So what does it mean? What does it mean? So this is the center one. So we have, this one will be cylinder number 3, 4, and 2, 3, 4, and 2. Because everyone pointing upwards. It is not upward, it basically at 0 degrees. This one at 0 degrees. Understand me or not? Is that clear, class? Hello? I have what? I have 52 candidates or 52 engineers to be. So please respond, yeah? So if you construct polygon, okay, now tell me, it is balanced or not? Does it balance or not? Anyone? This one balance or not balance? Balance or not balance? Balance or not balance, yeah? Balance or not balance again? Anyone?
Balance.
Not balanced. It's not balanced. Yeah, it's not balanced. Why? Everything is pointing upward. Well, so what does this mean? So if you construct polygon, you'll be getting all are pointing upward, all are pointing upward, all are pointing upward. With the numbers of, this one is number 3, the one number 3, number 4, number 2. Isn't it? It is not balanced. So how to balance? You put it away, you bring it to your starting point. Isn't it? It is not balanced. Okay, it is not balanced. Do you understand me? If you have 2 at the top and 2 at the bottom, it is balanced. No, it's not balanced because everyone is pointing upwards, so it's not balanced. So this one, this is the balance force. Balance force. Okay. If supposing you have a crank here, this one, look at here, how to balance the second. If you crank here, so where is your here? Here, yeah. So if this crank here, so let's say the crank be pointing that way, yeah, the crank. So you have to put a mass here to balance the system or to balance the engine. Okay, for example, yeah, for example. Any question? Okay, now. Okay, I'm going to move to the to the example, another example. This one is not very difficult. I already done this one, so this one is not balanced, pointing upward, not balanced. Okay, this one. So how much it is not balanced? We do not know because we don't have a numbers. Remember what we do have here. We have this one is F secondary, isn't it? F secondary is equal to the D. This one is the, it's not the MRD, it's MR omega square. It's the MR omega square. This one is cos 2 divided by N. This one, what you'll be doing here. This 2 omega is the position. Okay, now let's start another one. This one also I done earlier. I'm not going to do this one. What I intend to share with you to ensure that everyone is understand is to move to this one. 6 cylinder. After this one, we make 8 cylinder. Today we're going to learn only crank diagram. It's very important to know crank diagram before we start doing the solution. Okay, let's see now. Investigate. They are asking about the investigate because we do not know what will be the magnitudes. Just to say whether it's balanced or not. Investigate the balancing of the internal combustion engine or four-stroke engine with 6-cylinder, of course, with find order of given 1, 5, 3, 6 to 4. Okay, so the position of or the direction will be counterclockwise for your seats. Yeah, I'm going to solve this one. Yeah, I'm going to solve this one. Okay. So now, first, this is the option. You can put it in the graph. Sorry, you can put in the table, or you can also put in the, as I mentioned earlier, this one. Okay, everyone will be, remember, will be 120, 120. Either you can put this one in table, or you can also put in here. Wisely is put in table because you know that where are you basically when you construct a polygon later on. So what I am going to share with you is 6-cylinder, yeah, 6-cylinder, 4-stroke engine. Okay, now start with theta equal to 720 because we are dealing with 4-stroke engine divided by 6. You'll be getting 120, of course. And the find order given here is 153, if I'm not mistaken. Yeah, the find order given here is so what is your find order here? The find order given here is 1, 5, 3, 6 to 4. So 1, 5, 3, 6 to 4. So we know that the position for every crank is about 120 for primary. Correct. And you have for 240 for secondary. Because we already understand that secondary is always twice or double of the primary. So if you construct the polygon now, because we are going to investigate now. So you start with what? You start with, of course, your equation is F equal to this one, yeah? Equal to, you have M omega square R, or I can put it here very, standard equation saying that it's M R, then omega square cos theta. And we have this one, F, this one summation of S. This one will be F primary, we have the F secondary, isn't it? But of course, yeah, this one you will, I'm going to simplify this one. Otherwise, it'll be confusing a bit. Put it just one after another. Put it this one F primary, and we have this one F secondary. Is it M R omega square cos 2 theta divided by n. So this one you have primary. This one you have secondary. Okay, then you construct polygon. Construct polygon. Sorry, before you construct polygon, you construct crank diagram. Crank diagram. Okay, primary crank diagram. Primary crank diagram. Primary, put it there. Primary force. Primary force. Force. And you know this one is theta equal to what just now? It's 120. Okay, then we start here. This is our crank diagram. You know that one circle will give you a 360, then you divide it by 3. Divided by 3 because 120-ish. How do you know 120? This one, yeah? You calculated by 120. How do you know 120? This one? You calculated from the very beginning of your solution. This one is coming from, yeah. Let's assume this one, my reference number 1. And it is rotating where? Clockwise or counterclockwise? Rotating counterclockwise. Rotating counterclockwise. The distributor, rotating, or the crank rotating counterclockwise. So number 1 will be the find order. The find order tell us about number 1. Look at here. 1, 5. 5 will be here. Okay, now tell me why 5 cannot be here? Here mean that cannot be on my left. It is on my right. Why? Why? Anyone? Why it is here on my right, it is not on my left? Anyone? Anyone? Come on, 52 students in my class. So can anyone speak up or write something? Show that you are, participate in my class. Perhaps Tan can start with. Could anyone tell me why it is on the right, it is not on the left? Hello? Why it is on A, it is not on B? Anyone? I'm not talking to myself here. 51 students in my class. Because omega is clockwise, it is correct, yeah? Because omega is clockwise, it is correct. Because omega, this one is rotating clockwise. And this is the reference. So if you put 5 here, what does this mean here? If you put 5 here, let me clean up this one. If I put 5 there, so what happened to your firing order now? Your firing order will start with what? This one will be the last one. Oh, you need to change the direction, right? So the direction will be that way. You understand me or not? You understand me or not, class? This is not in your book, yeah? This is not in the book. This is based on the experience. So you've done so many examples, also many problems. Okay? So if you don't want to, respond, so I just leave it like that. So I just pretend that and just assume that you understand, yeah? So 1, then you come 5. Who did the 5? Where are you 5? 5 here. This one is basically 120-ish. This one is 120. This one was another 120. So out of 5, you have 3. 3 here. 1, 5, 3. The next one is just 6, pointing upward 6. The next one you have 2. And finally you have 4. Okay? Does it balance or not? Tell me. It is balanced or not? Balanced or not? Anyone? Balance or not? Yes, thank you. Balance, yes, it is balanced. So if you happen to construct the polygon, for example, yeah, so the polygon will be a very nice triangle, isn't it? 2 triangles superimposed to each other. For example, yeah, construct the polygon. So the polygon you construct, you will have here starting point here. So this one 1 and 6, 1 and 6. Then you move here. This one be 4 and 3. Then you have another one. Oops, sorry, 5 and 2, supposed to be 5 and 2 first, yeah. This one is 5 and 2, 5 and 2 of 2 and 5. Then we have this one. It's a 4 and 3. And it is a closed polygon. And it is balanced. You have 2 polygons superimposed to each other. Okay? Okay, now that is the primary force. We have another one, secondary force. Secondary force. What the secondary force now? 2 theta, remember? 2 theta. The earlier one is 120, now 2 theta become 240. So we start constructing polygon. So primary force. So this is the polygon now. This is the crank diagram. Let me put the let me draw a nicer. This one put it 3 just now. This one now is secondary force is 2 omega. This is number 1, our reference here. The firing order given as 1, 5, 3, 6, 2, 4, if I'm not mistaken. Correct, not? 1, 5, 3, 6, 2, 4, 1, 5, 3, 6, 2, 4, yes. So now, number 5, where will be number 5? And you know that this one is 240, 123, another 120, another 120. So, first number 1, So everyone were 240, isn't it? So you start with, for example, yeah, start with this one. Put it here. This one is theta. Put it 2 theta. This one define order. We have 5 or 1, 5, 3, 6, 6 to 4, 6 to 4. Theta now 0. This one's 0 degrees, correct? 0. The next one is 5 is 240, 240. So where be your 240 now? 240 will be here, isn't it? So 5. Correct not? After 240, what do you have? After 240, what do you have? After 240, what do you have? Another 120 will give you 360. Correct. So this will be your number 3. Correct not? Yes or no? Yes or no? Hello? No, it is not correct, Masila. It is not correct. Yes, yes. I purposely sometimes do this one, wrongly, just to ensure that you always be me. So twice of the 540 become 480. Remember, this one now is 240, 240, 240. Okay, now 480. Where will be the 480? Yeah, you put it here. Where will be the 480? So this one will be number 3. Yes or no? Number 5 correct. Number 3 is correct. Then number 6. Number 6 another 240. 240 and 280 will give you 720. Correct or not? Help me here. 480 plus 240. What do you have? What do you have? 720. Yes or no? So then number 3 here. Then you have number 6. Number 6 correct. Number 6. After 720, another 240. You will have what? 720 by 240. You have what? 960 correct. 960. What will be your 960 now? Will be here, isn't it? Number after number 6 correct. Number 2 now is number 2. Then after 960, another 240. What do you have here? 240. You will have 1,200 correct. So where will be number 4? Number 4 will be here. Does it balance or not? It is balanced. It is balanced. Yeah, it is balanced. Why balanced? Because you have a very nice polygon. You construct the polygon becoming very nice triangles superimposed to each other or overlapping to each other. 2 triangles overlapping to each other. So that is how to predict the balancing of the engine, typically for force only. Any question up to here? Okay, if there's no equation, look at here. If you have another one, we're still talking about 4-stroke engine, but now put it there, 8 cylinder. So they must provide the firing order. So how the firing order? So now let design firing order. Okay, let design firing order. So I'm going to explain to you how to design the firing order, or to share with you how to design firing order. So let's assume that we have one option. Option 1. You have 1. This one is 2, 3, 4, 5, 6, 7, and 8. This is cylinder number, yeah. The of cylinder number is sequential, isn't it? What you have to do is typically recommended that you cut into 2 parts. So simply mean that symmetrically divided by 2. This one will fall at 4. So you have 1, a friend of 8, 2, a friend with 7, 3, a friend by 6, 3 by 6. It is not symmetry. Sorry, I'm sorry, class. This one is not symmetry. Sorry, yeah. Wrongly constructed the symmetry parts, yeah. Symmetry line. The symmetry line will be fall at here. symmetry line. They want symmetry. So 1, 8. So your firing order now. Firing order will be 1, 8, 1, 8, 2, 7, 2, 7. The next one is what? 3 and 6. This one is 3 and 6. Then we have 4 and 5. Let's assume this is your firing order. Or you can also have another option, yeah? You can also have another option. Let's put it at 1 and 8. Astaghfirullahaladzim. Another option is, let me put another color here. 1 and 7. 1 and 7. 2 and 8. Not pairing each other. We have 3 and 6. Then we have 4 and 5. Another option. Option number 1, option number 2. Or you can also have 4 and 8, 5 and 1. You know, 2 and 6, 3 and 7, jumble up here and there. So the easiest part will be take the end to end. So I'm taking the easiest one, the option 1, the very common option, but so many options here. So let us see, we have this one firing order, yeah. Any could anyone tell me whether you understand or not about the designing the firing order here? And this is very important when you found that the occasion will not provide you the firing order. Then you need to know, you need to do this one, this option, couple of options. Could anyone tell me, do you understand about constructing the firing order here? Hello? Why my class is so passive this semester? No one bothered to answer the question. I just can keep on talking and talking without responding to you.
Okay.
Yes.
So the firing order for the option 2 can pairing just different from the symmetry one.
Yes. But you cannot before you pairing anything, you have to put this symmetry first. Okay, this one is, put this one first. Then you start pairing to each other. For example, yeah, if you have 4 cylinder, 1, 2, 3, and 4. So you cut 2 here. So the possibility of 1, 4, 2, and 3. Or you can also have 1, 3, 1, 3, 2, and 4. Or you can have 1, can also have 1, 4, 1, 4, 1, 4, 1, 4, 2, and 3. So these are the possibility. So the easiest option, as I mentioned earlier, Tanya, if you're Tanzanian, so you take the end to end, and before that you have to cut into 2 parts, symmetry. Then you take end to end. That is the easiest option, and easy to remember. Okay, now let's focus on this one. Okay, this one, yeah. Okay, I'm going to open up another file because this one is quite messy now. Okay, yeah. So we have 8 cylinder just on this one, yeah. 8 cylinder with firing order. Firing order we already calculated. So 8 cylinder. So before you start, what you need to calculate is the theta. Theta will be what? 720. Why 720? Because you are dealing with 4-stroke cylinder divided by 8. So 720 by 8. What do you have? 720 by 8 by 8. What do you have? Anyone? I basically can calculate this one easily, but I want you to respond, class. Thank you. Yeah, thank you. 90. Whatever you have here, 1, 8, 2, 7, 3, 6, 4, 5 is basically everyone will be located or positioned at 90 degrees. So that is the idea, isn't it? So after doing this one, then they must provide you this one 0, 90, 180, this one 270. Then if you're rotating that way, isn't it? And let's assume that your the direction of rotation is counterclockwise. So now put it here. Okay, primary force. So 1 I need you to understand this one before we go to the example. Very important, this one. Yeah? As I mentioned, this one is very crucial. Yeah. So your theta equal to 90 degrees. Put it here. Zap. You have 90. It's easy for you to construct, isn't it? You have this one. This one. Put it here. Number one, reference. Rotating that way, they provide you this one counterclockwise. So why will be number? What will be your crank? It will be your 8. It will be here, isn't it? It will be here. Then what? After 8 is 2, 7. This one is 2. This one is 7, right? Then what we have? 2, 7, 3, 6. This one is 3. Then we have 6. The next one you have 4 and 5. This one be 4 and 5. Balance not? Balance not? Balance not? Yes, balance. Thank you. It is balanced. What if when you have for secondary now? Secondary, where you have 2 theta equal to 180 degrees. So construct another one. Okay, now it is not omega, but 2 omega. Put it here. Doesn't matter. Huh? This one is your reference. So the next one is your 8. Where will be your 8 now? If this one is 90 degrees, now it's 180. This one is only 90 degrees. So 8 will be here, isn't it? So 8 will be here. Correct? So what next after 8 is 2. 2 will be here. Correct? Then 7, isn't it? Then you have 3, 6, 4, 5. You have 3 here, 6 here, 4 here, 5 here. So balance or not? Balance or not? It is also balanced. So that's about it, to predict whether it's balanced. But remember, yeah, it is comprising on primary force, and secondary force. Also a part of that, you primary couple and secondary couple. You cannot predict. Now remember this one. You cannot predict the couple. You cannot predict the couple. That because you have couple is primary, also couple secondary. You cannot predict this one unless, put it here, unless you know the magnitudes. So what is the magnitude? The magnitude is one in table. Okay, I will stop a bit, 1 or 2 minutes, because I want to move to the example, this one. Before I move to the example, I want you basically, look at what are the things that you miss or you blur about it. It's not clear about things. Then we'll start with example, because I'm going to do example very quick one, because you have the solution with you. So any question before we move to the example, and you look at the example, you can turn to page 129 in your books. Huh? Okay. Okay, now can we move on? Class? Are you still with me? I still have with me. It's 48 now. Okay, 3 or 4 students already left. Yeah. If it's not my responsible, perhaps to hold you in class, yeah, you can just left. It doesn't matter. It is not my my responsible to hold you in class, and except or unless you have in my face-to-face class. Face-to-face class, I can close the door. I typically lock the door when we are in class. Yeah. Okay, now let's now move example number 3. Turn to page 129. You don't have to do anything about it. You have the solution with you. I'm going to explain how to basically understand the equation. Okay, now the crank and connecting rod 4-stroke cylinder. Look at the 4-stroke, and you have your in your mind that theta now is equal to 720 by n. and your N will be 4 because you're talking about 4 cylinders. Okay, inline engine, because of course we are dealing with inline engine. Then we have what? We have running at the speed of 1,800 and 200 millimeter and 600 millimeter each respectively, and the cylinder are spaced 200. This one is the crank here. This one is the connecting rod. Remember, the connecting rod is the capital L. The crank is the up here, and each respectively, and the cylinder are spaced 200. This one is D. If you read book, they put L. It's the same. Either L or D is the same. D will be the distance. L will be the length between one plane to another plane. And in numbered 1 to 4 sequentially, from one end, and the firing order 1, 3, 2, 4. So you don't have to do anything but the firing order. So it does mention about numbered 1 to 4 sequentially. So you can put left to right or left to right, doesn't matter. So the reciprocating mass corresponding to each other is 1 kg. Remember, I did mention about this one is what? Identical. What does it mean identical? Every cylinder have a same mass of one piston, a piston of 1 kg. So investigate the balancing of the given engine. Okay, you investigate the balancing of the given engine. So these are the parameters. So let's think that, let's assume that I'm going to solve this one by using graphical. If you want to solve this one by using analytical, you can put this one all in equation. So let's assume that we're going to solve this one by graphicals. Graphical. So you have two choices here. Look at it very careful, class. One will be you construct the table, constructing the the position, crank position, primary and secondary. This one is by firing order. This one is firing order. The other one will be at cylinder by using the cylinder numbers of cylinder. Remember, 1, 2, 3, 4. This one is by cylinder number. This one is firing order given as 1, 3, 2, 4. So I would like to advise you to construct the table following firing order. This one, follow this one. I'm not saying this is not correct. Yeah, it's also correct. But look at here. You have 1, 0, correct, 1 and 0. You can look at the 3 and 180. You have 3, 2 is 360. Okay. So it will jumble up here and there. The position of the crank will be jumbled up here and there. Because remember that the position of the crank is always referred to firing order. You understand me or not? Again, the position of crank will always following what? Following what? Hello. Okay, you don't want to answer, never mind. When you ask me next time, I will also not respond to your question. Okay. So you will keep asking me later on. I'm not going to respond to your question either in text or in verbal. In oral. So I would like to advise you to follow this one, because the firing order, the crank position is always referred to firing order. So the crank position will not refer to cylinder number. Remember that. So follow this one. I'm not saying this one is not correct. Yeah, this is also correct, but you look at the position will be jumbled up here and there. And you found that if you have 16 cylinder, for example, it will get more messy. Okay, now, so the next thing is when you decided that you put this one in firing order. So I'm going to put this one in firing order. So you have all numbers. Okay, if you remember in rotating balancing of rotating mass, yeah, after constructing the table, you need to refer reference. You need to check the reference, isn't it? So here there is no reference because every plane are all knowns. There's no unknown plane here. Look at here. Every plane has all numbers here. There's no unknown planes. So the reference plane is always one in symmetry. You cut the engine into two parts. Okay, this one, look at here. You cannot take cylinder number 1 to be your reference. No, you have to what? You have to refer the symmetry plane or the symmetry position or line between the engine. If they have 8 engine, cut into 2 pieces or cut into 2 parts. Then everyone referred to this one. For example, this is reference plane, isn't it? For example, cylinder number 1 will be here is negative 200 and 100 is negative 300 or 0.3 negative, because you have the negative part on your left hand side. And you have cylinder number 3, for example, we have positive 1. So we have cylinder number 2, we have negative 1, sorry, negative 0.1. Then 4 will be positive 0.3. Understand me that? Then you put the product of the MRD here. So couples, the next one is the position, remember, theta and 2 theta. So the only difference now, what do you call it, their column with this one 2 theta, because this one is V. Okay, then how do you know that this one is by applying this one, because they already provide you the what, 4-cylinder 2-stroke 4-stroke engine with 4-cylinder. So you put this one, everyone will be incremental of 180 degrees, 180 degrees. Yeah. As you do this one, the next one is easy for you. The next one is what? Remember this one. The next one, after you do this one, the next one will be predict the firing order. Sorry, crank diagram. This is very important, crank diagram. So now look at here. I'm purposely do this crank diagram is along the horizontal plane. Earlier was only the vertical plane. This one is the sometimes I keep changing the position. Sometimes you can put this one horizontally, sometimes you can put this one on vertical. It doesn't matter, yeah. So this one will be along the line, horizontal line. So you have as such. I'm not going to explain this one anymore about the crank diagram, because we already done this one earlier. So if you do this one, you found that this one is primary crank position, yeah. You find that this one and this one is what, balance, 2 and 2 at both sides balance. You construct this one, it will show you another balance polygon. It is balance. So what it means? So you have the F primary equal to 0. So there is no primary force at the moment. Okay, then you move on. Now, listen up very careful this one, class. Remember, we haven't done this one, primary couple. Construct the primary couple referring to this one, construct primary couple referring to the crank position. The crank position. Remember this one? We cannot predict this one unless we have the numbers or the value. What is the value? As what you have this one. Okay, if I'm talking about primary couples, yeah, primary couple. So I'm focusing with MRD versus theta. MRD versus theta. This one is primary, this one is secondary. Okay, so look at here. You know that this one is balanced. The primary crank position says that it is balanced. But when you look at the moment or couple, you find that, look at here, 0.060 degrees. So the 0 degrees is supposed to fall here, isn't it? But because I have negative here, so it will fall the other direction. Because negative is supposed to fall that way, correct? This one positive. Because negative, it will fall the other way. Fall means they will go another direction. Okay, next, what do you have? Cylinder number 3, positive 0.02 180. So you go further left because 180 degrees here. So go further left, cylinder number 3. Number 2 now. You have negative 0.02 360. 360 is supposed to fall here, correct? But you have negative, so it will fall further left. Next one, last but not least, is positive 0.06 540. 540 will fall 180, so it go further left. And you know that it is not balanced. What you need to do now is to balance this engine. You bring back the line, and the line will fall at starting point. This one is starting point. Now it's balanced. Okay, now it is balanced. So you know that you need to know what be the magnitude. So the magnitude will be as what this one from polygon. You calculate here, become this one. This one will be here or here. The omega provide omega. Then you have as such 6.32 Newton meter for the primary couples. So in defining the couple, remember, yeah, defining the couple, you need to know the magnitudes. Force doesn't matter, primary and secondary force doesn't matter. Only couple you need the magnitudes. The reason is why, because you look at the numbers here, you look at the value, force are all equal. 0.2, 0.2, 0.2, because you have what? You have equal mass. Unless you're talking about compressor. You know the compressor? Compressor have what? Stages, isn't it? Double stage compressor, 4 stages, 6 stages, for example. So when you have a stages, what does it mean? So the volumetrics of the piston will be very different compared one to another. So you will have different mass and different radius. Here is the internal combustion engine. Is all the parameters are identicals. Okay. So now we move to the next one. Look at the secondary now. When you construct this is the the position crank diagram. This is what we call as crank diagram. You know that it is not balanced. You can predict it because we are talking about force. You can predict. No, the polygon will definitely not balance, isn't it? So if you look at here, so this is the force divided by this one is secondary. You can talk about secondary force. Look at it, 0.2 0 degrees. Correct. You go further here, 0 degrees. All that way, 0 degrees. The next one, another 0.2, 50. This one also 0 degrees, 0 degrees, 0 degrees, 0 degrees, as I mentioned earlier. So everyone was 0 degrees. So you keep move to your right, keep move to your right, and it is not balanced now. You bring back the line and fall at the starting point. So it will now balance. It will now balance mean equal to 0. Then you start calculating what will be the value. You take this one from that. Okay. Then omega given n can be calculated because n is simply the ratio. N is simply the ratio L by R. You have the numbers. You have 1053 Newton. This one is F. This one put it the F secondary. So in conclusion, yeah, you found that your summation of force is equal to force primary plus force secondary is equal to, of course, in vector. So this one 0 degrees plus, you have this one is what? Is 10.53 Newton. This one is 10.53 Newton, equal to 10.53 Newton for force, and pointing that way. And you have another one, remember? This one is summation of moment equal to moment primary plus or couple primary and secondary. And we're going to look this one a bit. So any question up to here, because we have another 2 polygon and we have a 10 of not more than 15 minutes to end our session today. Is that clear, class? Oh, yeah, thank you, Lane. So now we move secondary couple. This one is 6.32 primary couple. Primary couple, yeah, put it primary couple now. 6.32 plus another one. The last polygon, yeah. Okay, look at here. This is interesting, yeah. You will know that when you construct this crank diagram, it shows to you that it is not balanced. It is not balanced. It is not balanced here. But remember this crank diagram valid for, remember this one, valid for what? Valid for what? For only whether it's primary or secondary. Remember that. So it is only valid for forces, which is primary or secondary. Not valid for couple, because the couple you need to construct with this one. So couple, primary are done, secondary now. You have MRD versus 2 theta. Look at here. Okay, you have negative 0.060 degrees. It's supposed to fall to your right, but you have negative here, it will go to your left. The next one, you have what? You have positive 0.020, 360 is equal to 0 degrees, 0 degrees, 0 degrees, and also 0 degrees. So you will fall back with the units of 0.02. Then you move on negative 0.02, 0 degrees. So you will be go another direction. And finally, you have positive 0.06 at 1080 or 0 degrees. So you fall here, and you found that you will fall at starting and ending point at the same place, because this line is basically overlapping to each other. So it is now balanced. What you have is the M secondary equal to 0. Even though from the very beginning you predict that by using the crank diagram, it's not balanced. When you construct the actual polygon, it is balanced. So that is the reason that I say that this crank diagram is only valid for forces to predict whether it's balanced or not balanced. Okay, so if I can do this one, so you have this one 0, and finally you have this one equal to 6.3 Newton. And in practical, remember, this one, all the secondary cannot be done because it's partially balanced. Remember that, yeah? In practical, all the secondary cannot be done. Okay, all the secondary in cannot be done. Whether you're talking about secondary force or secondary couple cannot be done. That is why the reason is that mentioned to us only partially balanced. Any question up to that?
So doctor,
Yes, please.
the couple secondary also cannot be.
Sorry?
The secondary couple also cannot be reduced to 0.
Are you saying that this one reduced to be 0?
If the secondary couple has value.
Okay. Any secondary magnitudes, whether it belong to force or couple, cannot be done in practical. It simply means that this one okay because it's 0, correct? In practical, yeah, this one is not okay, correct? Because this one secondary. The reason is why not okay, because you cannot you cannot run the engine. You cannot run the engine twice. Meaning twice is 2 omega. And the other one, you have to what? You cannot also position the crank by 2 theta. The reason is why, look at the equation. Oh, let me use another color, sorry. Yeah. Look at the equation from secondary. Yeah. We have the F. This one is F total equal to the F M R omega square cos theta. This one, it shouldn't be a problem. When you go to this an F primary, this one the M R omega square cos 2 theta by N. So this one now F secondary. So you cannot do this one by putting the speed twice and also the position of 2 theta. So that is the reason. And you know that you have a very small here, and this one that the bearing has to take over. Mean that the bearing has to withstand on the secondary parameter, whether secondary belong to the force or couple. In this one, very nice because you have 0 here. Am I answering your question, Tan?
Yes, doctor. Thank you, doctor.
Okay. So, okay, if there's no question, we still have another couple of minutes. Let us now finish at least example number 4. Yeah? Okay, example number 4 is not very difficult, class, because it is a very small capacity engine. We have 3 cylinders, typically Viva or Kanchin or, if you're talking about Fiat, yeah, right? or 101 if you're talking about Hyundai, yeah, 3-cylinder, any 3-cylinder vehicles. The crank and connecting rod is 4-stroke with 3-cylinder inline engine running with the speed. This one is 200 and 400 to be the speed, and also the what do you call it, the radius. The cylinder numbered 1. This is not 1 to 4, yeah, it's supposed to be 1 2 3. Check your notes, yeah, whether it's correct notes. Numbered. Oh, you don't have a number. Your book is correct, only my note. This one is numbered 1 to 3 in sequence, meaning that 1 2 3 is not 1 3 2. And one from one end doesn't matter left or right, but the final order given is 1 3 2. So the reciprocating mass given 1 kg. Investigate again the balancing of the given engine. Okay, so this is the one. You construct this is what you call schematic diagram. Yeah, it's a schematic diagram. You construct the schematic diagram, then you divide it into 2 parts, and suddenly you found that the reference will be found at cylinder number 2. Cylinder number 2 now becoming reference. So then you put everything in tables. You have 1 3 2 following defined order. Remember, 2 will be your reference. As 2 become your reference, D will becoming 0. So everyone refer to 2 now. Okay. And it is not due to the unknown parameter, because it is one fall on the symmetry line. And then when you have this one, you have a 4-stroke, you have to divide it by 3, you have 240. So everyone will fall 240, 240. This one all given, this one all equals, this one is the force, this one is changing because you have to refer to cylinder number 2. And this one is coupled, it's not very difficult. This one is the sequential, or perhaps, sorry, this one is gradually increased by 240, 240, 240. It's also 240 by 480 by 480, which is double of the theta. Theta become 2 theta. Then start constructing polygon. Look at the polygon. Primary force. This one you've done, already done. You can put at vertical, you can put at 1 at vertical. You can also put at 1 at horizontal, doesn't matter. So now you have what you have here. You know that from the crank diagram, this one is crank diagram, yeah? Or sometimes we call crank position or crank diagram, it is the same. Okay, you found that it is balanced, so this one also balanced. Okay, this one balanced, is this one is balanced. And you another one, you construct another one, this one. Now it's couple. Couple will be here. We are talking about primary versus theta. So what you have? Negative 0 degrees. 0 degree will fall here. It is negative, so it will not fall at 0 degree, it will fall at 180. If I can see this one, you have fall the other direction. It's opposite direction. Then you have 0.2, 240, measured horizontals, you have this one. So, is it correct? Yes, it is correct. Yeah? It is correct. Cylinder number 3 here. Okay. Let me check. Okay, your notes. Correct, not your notes? Yes, it is correct, yeah? Okay, you have this one, then it is not balanced, so you could close the polygon. Close the polygon. And you know what will be the results. You have the results. You can do this one on your own, yeah? Then you do the same thing. This one, because force can follow this one, valid, so it balance. This one is not force, this one is a couple. You have to follow this one, by this one, you have this one, it's not balanced. Okay, of course, after you do this one, you have to do this one. The F total is equal to F primary plus F secondary, all in vector. So you found that the F secondary, put it there. What therefore F secondary just now? The F secondary, this one is correct. primary false 0, primary secondary is also for this one, it becomes 0. 0 plus 0 equal to 0. Another one, M equal to MP plus MS. Put it there equal to, you have the numbers here. So this one secondary false, this one is secondary couple, 612, huh? Secondary couple, primary couple we have 1229. So it's so huge here. 1229. So 1229 plus another one is 6 something. 614.7. 614.7. You have this one. So that will be the results. Huh? This one, okay, very nice. This one is not so nice. This one you can do in practical. This one you cannot do in practical. Okay. And if you want to add it together, you have to look at the direction, huh? whether it is same direction or not same direction. If you look at very carefully here, class, look at the one be pointing here, the other one be pointing this one. So you have one, you are basically two, because this is vector, yeah, you have to resolve into x and y. You can do this one on your own, yeah. Let me go back to the a bit more, yeah. This one I'll be doing inshallah next meeting. I'm going to do this example number 5. You don't have this one in 5 cylinder in your books, huh? This one is the extra example in class, huh? So I will stop here. So I'm not going to to continue, because if I continue, it's only halfway of your work. Yeah. So I'm not going to leave you with the halfway of discussion. Yeah. So any question? Any question?
So far, okay, doctor.
Lee. Thank you, Lee. Okay, your test will be inshallah tomorrow night. Please check your platform of e-learning platform to ensure that it's activate and good in conducting the test, because everything will be submitted in the e-learning. So but remember, yeah, when I know that during submission time, everyone will be submitted at the a particular time, so it will be congested a bit. Okay, it will be congested a bit, and you know that the system will allow you to submit on time. So if you exceed the time, it will not receive. Remember that. If you exceed the time, it will receive. But I asked my friend to actually make another buffer to ensure that those are students, sending or submitting, but it will taking a couple of second or time, a minute, yeah, to ensure to put another file to ensure that all the submission beyond or exceed the time will be put in one table, so that we can also see your work. But after trying so many times, and this is not your first time in your online test, after trying so many times, you find that you unable to send your work. You can also send to another file, which will be given by Dr. Matlusid on the personal personal what they call email, his personal email. No one will allow to send to he or her lecturer at the moment, yeah. So we see what happened in during the test time. It's also an occurs in your exam time later on. Okay. So I think a couple of number of you mentioned about your e-learning is not functioning. So I will provide you a person in charge to look at your e-learning platforms. Okay, thank you, class. Thank you for being with me. Thank you for those who are responding in the class. I'm really happy when you respond. I'm not, no, you are basically not, let me talk to myself here. I hate to conduct the online teaching, because I can see you. I can basically see how your face, your action, or whatever it is now, because I can hear your voice on your writing now, your text. So hopefully I can see you next semester if I've been invited again by, actually I'm not retired now. If UTM still need me, ask me to conduct a course, or inshallah I meet you again in your later year of your course. Yeah. At the moment, I'm still conducting a couple of subjects or course. Yeah. So thank you, class, being with me. Thank you, responding. Those are active in the class. Wish you all the best in your test one. And with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh. And stay safe, stay healthy, and stay study. And have a nice day. Thank you, class.
Thank you, Dr. Wa'alaikumsalam.